Hello everyone, welcome in Salesforce Apex Hour. My name is Amit Chaudhary. I am the founder of the Apex Hour, and today we are going to talk about Salesforce Lightning Enterprise Pattern. And we have a great star with us, John Daniel. So I will not going to take too much time here, and let me hand over John for his introduction.
Thank you, Amit. Appreciate you very much the invitation to come speak for Apex Hours. Like you said, my name is John Daniel. I am a Salesforce MVP. I currently am a Salesforce architect and practice lead for a company called B3 Group, and I am a certified application architect, system architect, and platform developer certification holder. Excuse me. I co-lead the Richmond, Virginia Salesforce developer group, and I've been involved in lots of open source projects out there, including the Apex Enterprise Patterns group, which we'll talk about in a little bit. And I've also been the technical reviewer for several different books. And yeah, you can find me on Twitter at @OnJohnandDaniel. As far as the topic today, we're going to discuss a lot about Apex Enterprise design patterns, and we'll get into a little bit of a couple of object-oriented concepts, and then we'll hit the what they call Salesforce Lightning Enterprise Architecture patterns. We'll get into the deep dive about selector, domain, service, unit of work, and then the application factory, and then we will review some of those frameworks in depth. And so let's get into it a little bit. What are enterprise design patterns? They have basically enterprise design patterns are tried and true patterns around constructing your application. The term enterprise architecture or enterprise application architecture was first promoted by Martin Fowler in 2003. He has a book called Patterns of Enterprise Architecture. And he's basically the father of enterprise design. He's generally accepted as the father of enterprise application design patterns. And then back in 2014, Andrew Fawcett started adapting those patterns to the world of Salesforce. And Andrew Fawcett at the time worked for Financial Force team. And he wrote a book. At the time, it was called Force.com Enterprise Architecture, but now it's the latest edition was released just last year, and it's called Salesforce Lightning Platform Enterprise Architecture. But you know, these patterns that we were talking about, when Andy was working at the Financial Force, he basically, along with the development team there, created two open source projects. One of them is called the FFlib Apex Mocks, and that's just a test mocking framework for unit tests. But then the thing we're going to talk about in depth today is the Apex Commons framework. And what they did there was they codified a lot of these principles that you were hearing from enterprise application architects, and they built and baked them into this particular framework. And we'll see why this framework really it shines and really helps developers organize their code so much better. Now, I included the link right there because even though it's called Financial Force Library or FFlib, it's now been turned over to a community group. It's called the Apex Enterprise Patterns GitHub group, and you can find us on github.com at /apex-enterprise-patterns. And there you can go and find all of these repos plus a couple of other ones, and all of them are dedicated to what we believe are the best enterprise patterns for development in Salesforce. So that's a little bit of overview of the design patterns. So let's talk a little bit about basic OO concepts. There's a lot of principles that are underlying the concept of enterprise application development, and what you find in really good implementations are the application of some of these principles. And we'll talk about the separation of concerns principle, the dry principle, solid principle, and even get into a little bit of dependency injection before we're all said and done. When I talk about separation of concerns, especially with enterprise software, enterprise software is very large. It's lots of different projects, lots of different code bases, and it's constantly changing, and it's very hard, it's very complex to keep it's very hard to keep up with all of that all over time. And so it's important to, when you are organizing your code, it's important to establish a series of boundaries. You know, the Salesforce architect, Stephen Herod, he's the Salesforce practice lead for Accenture, worldwide practice lead for Accenture, I believe. And he said one of the biggest problems that we have right now in the world of Salesforce is there are not a lot of clear, definable boundaries amongst the code bases. And so what we're going to talk about in separation of concerns and really these frameworks helps establish a lot of these boundaries going forward. So when you think about separation of concerns, you want to make sure that you define and organize your code into various layers. And so I've got a couple of layers listed here. And typically what you're talking about is like presentation layer. And so that's really your pages, your logics, the old Visualforce pages, and even the Visualforce controller, the Apex controller, is part of the presentation layer. You know, the items that are in the presentation layer, their sole responsibility is about presenting the data. Their responsibility is not what might be argued the business logic layer. And the business logic layer is, you know, it's Apex, it's certain elements of the flow and process builder and approval processes, but that's where logic and business rules are applied to your data and executed. And then, you know, that business layer logic, you know, you want to make sure that your code and your Apex is very specific to a purpose. And so you want business logic layer code to be, say, separate from the responsibility of accessing the data. So you've got the data access layer, things like the SOCL, SOSL, the Salesforce REST APIs, you know, certain flow data elements like the get, the create records, the update records, get records. All of those are about data access layers. And then finally, you've got what is the database layer. And essentially, that is the custom objects, the fields, Apex triggers, all of these things that work directly with the DML. And so when we talk about separation of concerns, we're talking about the organizing your code so that it has a specific responsibility. And you don't want a piece of code that has more than one responsibility. And that's really what the theme of separation of concerns is about, because when you get more than one responsibility, you tend to get into problems with maintenance and scalability of that code. Again, we'll talk about it more throughout this presentation. Another simple principle is just this guideline that says the DRY principle. And DRY is, the word DRY is an acronym, and it means don't repeat yourself. And so basically that underlying thought is every bit of knowledge, every bit of functionality should exist in your code base in one spot and only one spot. And so if you organize your code with that kind of thought process in mind, then you're going to be in a lot better position, because again, think about it. If you have a class that's responsible for querying of the account object, and you add a new field to it somewhere, to the account object, how many places in your code base do you want to go and touch and update these things? And if there's a bug in the logic that does maybe some email sent or an integration out to off-platform service, you know, do you want to have that integration in multiple places, or do you want to have it in a single spot? And so if there's a bug, where do you go to fix it? If it's a single spot, then it's easy to find. There's another principle out there that's called SOLID. And so SOLID really is, again, the word SOLID is an acronym, and it really stands for, it's the beginning letters of each of these 5 principles. And so I think it was actually Uncle Bob that actually coined the SOLID principles, and I could be wrong there, but still. It was 5 basic principles about how to organize your code, especially when you get into object-oriented designs. And so the S stands for single responsibility principle. Again, it's very similar to the idea of a piece of, or the DRY principle, but basically a piece of logic should exist in only one spot, and it should, and that piece of logic or code, be it a class, a module, a function, should have the responsibility over that one piece of thing. The open and close principle, really what that's talking about is when you design something, you want it to be easy to extend, but not necessarily want to have to modify it all the time. And really what that's talking about is when you get into certain areas of object-oriented design, you might have a piece of functionality that does, some piece of function or piece of logic, and there might be an extension that you need to make to adjust for a specific use case. You might have a vehicle class, and it deals with various basic common things around vehicles. They travel, they have wheels, something like that. But you might have a Porsche car class that extends the vehicle class, but it's more specific. It's more tailored to the specific Porsche instance. And so it's around, you've got to make sure that you design your class so that the basic functionality of the vehicle doesn't change, even though you're modifying it to represent a Porsche. And so, again, these principles here you can have entire seminars on, but we'll just highlight them a little bit here. The Liskov substitution principle, what this is basically talking about is, we have the concept in Apex called interfaces. And if you're not familiar with them, basically they define contracts of how or what you can expect to have a class do, the behavior of a class. And so really it's, what you're trying to do is design your code so that you don't have as much tight coupling. You don't have as much tight logic depending on one class to another, because that creates maintenance problems when you go to make changes. So when you're looking to design and work or set up your classes, you get into concepts called loose coupling, and we'll talk about that a little bit farther. But this principle is really about the concept of design by contract and loosely coupling these things and working from interfaces instead of the actual class that's go. And we'll see examples of that in this presentation as well. The interface segregation principle, again, it's all about working with interfaces, but this particular one says, you shouldn't necessarily create classes that have to implement methods from your interface when they actually don't need that functionality. And then the dependency inversion principle, basically, again, it's a concept of how you set up your dependencies. Are you dependent on abstractions? Are you dependent on generalities of a concept or a piece of logic versus, say, the specific implementation? And so, again, I'm glossing over these subjects. There are huge topics in the world of object-oriented design and software engineering. Again, I implore you to go out to places like Wikipedia or just do a search on some of these aspects to get more information about this, because these are very vital subjects. But the last kind of concept that we'll talk about a little bit is show about dependency injection. And basically, this is just a technique to allow you to add something or provide a dependency at runtime versus having it always known, always understood as to what's going on. Again, this promotes the concept of loosely coupled system, and when you get in a loosely coupled system, you can swap things in and out much easier. And so if you think about it, you can replace sections of code or logic and swap them out with other sections of code that do the same thing or produce similar, or I don't want to say produce similar results, but they operate the same functionality, but they may do it in a slightly different way. And again, it's the difference between like a Toyota car versus a Porsche car. Again, they're both cars, they're both vehicles, but you might want to have a process that works on a car, and you might want to, instead of hard coding it always to the Porsche car, you might want to bring it in dynamically at runtime depending on the circumstances, and you might swap in the Toyota on the fly. And again, that gets into sort of a loose example around the dependency injection concept. So again, Wikipedia, start with Wikipedia and then go find some really good books. Again, we'll talk about some of these books at the end of the presentation, and there's a whole host of them out there. So I think in 5 minutes I've done or tried to summarize, literally hours worth of discussions. So Anyway, let's move on a little bit. We talked about it. We talked about that there is a specific framework out there called the FF-led Apex Commons framework, and this framework is the key fundamental idea or implementation around what is called Apex Enterprise Design Patterns or Lightning Enterprise Design Patterns, depending on what term you use. Again, it was originally created by Andy Fawcett and the Financial Force development team years ago. And when you sum it up, it really has a lot of different value adds, but it really focuses in 5 areas: in the selectors, domains, services, unit of work, and then finally the application factory pattern. And so we're going to go over all 5 of those for the remainder of this talk and show you the value of how this framework really comes together. So with that, we're going to start with the selector pattern. Now, the selector pattern, what is it? Basically, the selector pattern deals with queries, accessing of queries. It deals with who or what class should be doing the queries. So think about it. If you have a query that you have over the account object or a query over the opportunities object, you know, do you want to put several different queries throughout your entire code base? If you have 1,000 Apex classes in your Salesforce org, how many times, how many places do you have a query for account? How many places do you have a query for opportunities? It could be, you know, several different places. And now think about the maintenance around that. You know, how do you deal with that? How do you go again? How do you make changes to those queries? What if you add a new custom field to the account object? Do you have to go and touch the 47 different places that you have a query out there? But if you have a selector pattern in place, what you end up having is you have a class, a single class that is essentially takes ownership of queries around that S object. You know, and the pattern, as I listed here, it encourages bulkification. You know, bulkification is very huge in the world of Apex, especially. And so, you know, it prescribes certain things, like the parameter should have sets of IDs and always return lists. And but you can also utilize the selector pattern to return either lists of S objects or even database query locators. So let me show you an example of really what I'm talking about right now. So like I said, there was an example. You might have a query out there, and this is basically a static inline query here. It queries, it does the basic query over the opportunity object, and it has an inline query around opportunity line items. And within that opportunity line items query, you have a subsection that goes out and grabs the information from the price book. And then you also want the product information from that price book entry. And you might also want the price book records itself related to that price book entry. So this is a fairly involved query for the opportunity. Now, that's fine, but at the end of the day, this is just a big static query, and there's some issues with it. To start with, it's difficult to maintain. Again, it's a very complicated query. You might have to add multiple lines, but that's just one instance of it in the first Apex class that you have. Again, what if you have 47 classes out there, all of them querying the opportunities object? You know, in that kind of paradigm, it's not very centralized. You know, if you need to update a field, then you're going to have to go change 47 different classes to get that new field in there. And another issue with that kind of a random query is what I'm calling, it creates an inconsistent S object creation. What I'm talking about is, you know, you might have an S object that has the custom field, you know, the custom field that you're interested in, but there might be another example of that query in another class that doesn't actually add that extra custom field in. And if you've done that kind of work, you always see this S object exception. The S object road was retrieved via the sockle without first querying the requested field. What that really means is you've got this record, you've queried it from sockle, but it doesn't have that custom field that you were looking for. And when your Apex tries to access that custom field, it gets a problem. So again, it's problematic because, you want a consistent, you want to be able to not have to think, where did I actually get this record from? And is this is this record going through the triggers correctly? And is there other logic that I'm not actually anticipating trying to access fields on it and stuff like that? And so again, this, the static query, it can be argued that it sort of violates the separation of concerns principle, because again, that query might be in some specific service class. That does, it might apply a discount for an opportunity, but there might be another one that's, there might be another class out there that wants to query the opportunities, maybe to archive them or something like that, or a third class out there that queries opportunities and wants to send it out to an offline system, something like that. The problem where it violates this principle, though, is you might have several different classes that all have responsibility for querying the opportunity. And if we can correct that, and if we can clean that up a little bit, that would be helpful from a maintenance perspective. So the solution around selector patterns is really focused around what are basically called dynamic queries. Instead of having an inline, you utilize the, and you'll see this in an example in a minute, you utilize the basic, the Apex class database.query, and you basically pass it a string. And so the Apex common selector pattern makes this all possible and makes it easy to manage. Now, when we go through these patterns, I'm going to talk about a couple of different classes that are relevant to that particular pattern, and you'll find them in the Apex common, the FFlib Apex common project. And for the selector pattern, there's three key classes here. The first one is the FFlib query factory. This query factory, its only purpose is to assemble the queries on the fly, and I'll show you an example of that and how it works and how it manages that. But again, it does it in a systematic way and in sort of much easier, more predefined way than trying to manually add every field in a static query. The FFlib S-object selector, this becomes sort of this is the abstract base class that all of your selector classes will extend. And so that provides the extra plumbing to manage the query factory and manage the convenience methods that are needed and throughout the Apex common framework. And then finally, the FFlib I S-object selector. Now, if you see an I right there, right after the underscore, that means it's an interface. And so again, this is the base interface for all the selector pattern classes, and we'll talk about why we need lots of different interfaces coming forward. So, an example. So the other project I want to call your attention to is the FFlib Apex Common Sample Code project. Again, it lives in that Apex Enterprise Patterns GitHub group, so you'll be able to find it very easily. But this project is the project that you really need to study if you're going to focus and learn the Apex Common project. It has all the working examples. And so the working example for the selector pattern that we're going to look at is called the opportunity selector. And so I'm going to briefly switch over to that class, and you should see the opportunity selector now. And so the opportunity selector is pretty straightforward. But it doesn't look like a traditional querying class. It has a couple of different methods, things like an S-object field list, which is defining a couple of different things. It's got a couple of different methods, and then it's got some methods like select by ID. And that select by ID looks like it's referencing an internal method. And there's other things like select ID with products. And again, this is just, again, assembling a query. Here's that database query that I was telling you about, command. But it's using a lot of query factories to get at the information that it needs. So this is kind of a basic idea of what a selector class looks like. Here's a method that deals with query locators instead of just returning the method. So you can look at this in depth a little bit further. As I said, it extends the S-object selector, and it has also an interface that it works with. And so we'll talk about why it needs to work with that in a second. So when you deal with selector classes, there's a general naming convention. There's a general naming convention to all of the different types of patterns in the Apex Common project. I'll take a brief segue and say that these class naming patterns are one of the most powerful features of the enterprise patterns and the Apex Common framework, because just at looking at the class, you can easily understand what it does and what its purpose is. So for example, this opportunity selector, it has, among other things, there's an optional section prefix. So that might be, if you have a very large complex org, you might want to segregate or group applications and modules together with some sort of prefix, and generally it's a small prefix with an underscore. I don't have it listed here, but you can add that if you want to. But generally, the selector name, it begins with the S object that it's responsible for, and it's the S object name in plural form. So it might be opportunities, it might be accounts, it might be users, or whatever the S object is that you're looking for. And then it always ends with the word selector. So in the opportunity selector, it's the opportunities, and it's a selector. So you know immediately what this class is all about. The selector pattern also gives you the ability to work with complex queries. And I will draw your attention to the opportunity selector method, select by ID with products. So the inline query that I showed you, and I'm going to show you again, is totally managed or converted into this particular method. So it's a great subject. I don't want to dwell too much on it, but the power that it affords, the selector pattern affords, with working with multi-object queries is amazing if you really take a look at it. So when you set up a project and you set up a selector class for a specific S object, there are a couple of common classes that you always want to set up. And so, say for example, you had a custom S object and you called it foobar_C. Then if you have a foobar_C S object, then I typically am going to see up to 4 different classes. The first one is going to be foobar's selector. Notice the plural name, not foobar, but foobar's selector. And then the second one is the interface, the iFoobar's selector. And then there's always a foobar's selector test. And then if you need a good exception class, then the foobar selector exception. And so we'll talk about what some of these look like and what goes into each of these classes in a sec. So for the foobar selector or the selector class, like I said, you typically find that it extends the fflib S-object selector. It typically implements the corresponding interface. And for in the last example, it was the iFoobar's interface or the opportunities interface. And the interface is important because, again, this whole framework is built around separation of concerns, layering this code into various things. Why that's very important and helpful is that it helps during unit testing and integration with Apex mocks. And so, Amit, maybe I can come back and talk about Apex mocks because that's a whole nother subject, and it's very, very powerful testing framework. But think about it. If I was able to find a way so that I could run some code, and if that code was actually doing a call to a querying class, then maybe I would want to exercise this code and not have to bother with going to the database and querying that class. Well, if I could mock out the querying class and replace it with just a mock using the stub API from the platform, that will always return the same records that I build into it. It's a very interesting concept because it always produces the same results over and over, and it makes test setup so much easier because you can focus and break the process and the logic up into smaller units and focus the unit tests on each one of those. So I digress a little bit, but if you haven't checked out the Apex Mock project, again, go to the Apex Enterprise Patterns group, find the repo there, and on the README page, you'll find a lot of information about where you can get more information about Apex Mocks. As far as the selector class is concerned, they typically implement a couple of different methods. Again, there's one method called the schema S-object, which is the get S-object type, and that just returns the type of the class. This tells the framework as a whole what S-object you're really dealing with, so it dynamically can bring some extra classes or get the fields and find out what's needing to do. You will always find a list opportunity or a list of classes that, and really it's the method select by ID. You usually find that method every single time. And that's basically just the simple, I'm going to query my S object by a specific ID. You find the get S object field list. So remember if I was talking about when you've got static queries, it's difficult to get them always to have the same fields in every plan, regardless of where the record was queried from. So this selector pattern class, this allows me to define the minimum number of fields that are always present when the selector class queries. It's a very simple concept, but a very powerful implication there. And then finally, what I typically see is a static method that is basically the new instance method. And this new instance method, and we'll take a look at it in just a second, actually calls out to the application factory selector. And so, again, this provides an extra hook or layer of separation to, among other things, work with the interfaces versus the actual concrete implementations of the class, which again helps loosely couple a lot of the code base. But it also provides a hook that we'll talk about that allows you to mock certain selectors and domains and service classes to make use for the Apex mocks framework. So again, let's just take a quick look at our selector. Here's that new instance method I was telling you about. It's a static. It returns the interface, not the actual class. And again, it uses the application factory. Here's that method about the S-object field list. So this basically is just returning a list of S-object fields, and I can define the S-object fields that I want. Basically, I'm guaranteeing that any query that utilizes this class will always have these fields. Again, that is that S-object type method I was telling you about. And basically, it's just give me the opportunity S-object type. This allows the framework to understand which S-object this class is supposed to be behaving for. And then I said there was a select by method, select by ID method. And again, it just uses the parent convenience method, select S-object by ID. And from there, it makes it very simple to design otherwise. Now, the rest of these queries, or the rest of these methods are custom added. They were added because I needed a specific thing. So, but again, you know, through this method, we take this static query and we replace it with that method that I just showed you. And there's a couple of different things in this query. When you look at this method, what you're talking about is you understand that each selector class manages a single S object. So in this case, we're dealing with the opportunity selector, so it manages the queries of the opportunities. It does not manage the queries against the opportunities line items S object, because that is a totally different selector. And as you see right here, the opportunity line item selector is actually called upon to help build the logic that is for this query. But really up at the top line there, we see that each query basically uses the query factory to start assembling the mechanics and the basics. So it's bringing together a string, and that string is the SOQL query. And so the select and the adding of the fields from the opportunity, all of that string that produces the SOQL query, the query factory is what is used to make that happen. But like I said, there's some methods that are available to add fields from other selectors. So there's fields like when you want to add a subquery or subselect query, then you can reach out to the other guy selectors or the other S-object selector and use the method add query factory subselect. And so again, you can get more details on this from the code base, but that allows you to add subselect queries. And then if you need to include parent fields from other things, you just draw on those parent objects selectors and add the extra fields in there based on the mechanics of how you're looking. And then once it's all said and done, you just have this, you have the query factory, the opportunities query factory is assembling all this configuration information. You give it finally a condition, set condition where ID in ID set, and then you execute this small method right here, to SOQL. And that basically returns a string that the core database query method can utilize, and it'll do the query, and you cast it to the opportunity, a list of opportunities, and you return that list of opportunities. So it's a different paradigm than, say, the original thing, but it simplifies maintenance so much more, and it takes this large query in the service class, and it really takes every query that might be looking like this, and it reduces that from this large behemoth down to just this one line. So this is the only line in your service class that you do. You will call the opportunities selector .new instance select by ID and product, and I've passed the opportunity line IDs that I want, and so all of that comes on. And I can add this code into the 47 different Apex classes that are dealing with opportunities. I might do multiple methods depending on what's going on, but I guarantee that the list of opportunities that come out always have the same constitution. They always have the same field. So again, when you think about it in that large scale, it becomes a very powerful thought. A couple of quick comments regarding usage. Selectors usually, they can access other selectors, like we just saw that during the multi-object relationship query, but they never access domains or service tier logic or client tier logic. They are exclusively focused on queries. So that's the selector pattern as a whole. Again, we're going through it a little bit more, but I'll give you some more information about how to get more, research more about these patterns at a later time. So let's move on really quick to the domain pattern. So again, what is it? The domain pattern is, again, it's a class that's responsible for the business logic that is specific to a single S object. Sometimes you would view this as a fine-grained service. I've heard them referred to that way. But basically, it's a wrapper around the records that you're working with. So think about it from a trigger context. When your trigger context activates, you have a group of records. The records have been updated. And so you basically have this wrapper class, a domain class, that wraps all of these records, and now you can apply specific logic to these things. Its focus is about applying business logic to the records, but its focus is not managing the persistence of those records. It does not do the database updates. It does not do the inserts if they're new records. But it does focus on defaulting and validation. And once you have that, it's very easy to execute the logic across all of your work. So again, it encourages bulkification methods and practices in your Apex code. So when you talk about domains, there's two real classes that you stay focused with: the fflib S object domain, and then alternately the fflib I S object domain class. And some examples in the sample code project are the opportunities domain class and then the opportunities interface. And so let's jump over there real fast and take a look at those classes. So let's see, where's the opportunities? Here we go. So the opportunities domain class looks something like this. Again, it establishes, it extends the S object domain, and that is the plumbing that it needs. It extends the service interface, and it has a couple of methods to instantiate the class as a whole. And it has a specific constructor. Again, the constructor is passing specific records through. And some of the other things like on apply default. So it has a couple, because it extends from the S object domain, it has a couple of key methods that you can tap into. And so things like apply defaults. Well, you can always take that and loop through the records and apply specific defaults based on whatever settings you're looking for. Or you might have some validation logic, either for new records or for older the previous version of the records, existing records. And then it has various hooks methods that you can override, things like on after insert. There's on before insert, on after update, on before delete. These are the trigger contexts that are available to it. And so you can work with you can apply or put logic into it that allows you to focus. You can put logic into it that allows you to work with that particular trigger context and focus on it from there. And then you might have other logic that is specific to the records. You might want to apply a discount to these records. Well, if that's the case, then what is the discount percentage and the S-object unit of work? And we'll talk about that a little bit later. So basically, you can go through it, figure out some sort of discount factor, and then you can query these opportunities. If the line items are less, then you can add the opportunity amount, and then you register those changes. And if there's line items to apply the discount, then you can also apply the line items to discount again. So this is line item discount, add all. And forgive me, I'm walking through this a little bit, but this is the domain for the opportunity line items. So again, just like in, well, actually, I'll come back to that in a minute. Let's go back to the presentation. So typically, there's two classes: the domain and the domain interface. Again, it allows us to help with the mocking and the least coupling principles. Class naming pattern, again, it's pretty straightforward. There is either an optional prefix, but generally you see the S-object in plural form. So it's the opportunities class, the account class. We know just by the plural nature that is the domain object for that class. Typically, if you have, you're creating a set of domain classes for an S-object, then you're going to have four basic classes. Again, the domain class for foo-bars, the interface for the domain, and then the test, and maybe a domain exception. So when you look for a domain interface, all you're setting up basically is that you want the interface to extend the S-object domain interface, and then you want to add any methods that would execute some change or alter the logic of the record somehow. And then for the domain class itself, you want to extend the S-object domain class. Again, implement the domain interface, and then implement the following methods. First of all, you'll define a class constructor to pass the records through, and that constructor passes the list of S-object records through. You'll define two static methods, both of them the new instance method, and basically it's either the list of S-object or the IDs. And so they basically reach out again to this application factory, which we'll talk about it a little bit more, and just allows you to set up the domain class in a very consistent manner. You override, you will add the extra methods that we talked about, like the on apply defaults or validates or after insert or before insert, before update, whatever you need to override the key features and the key methods that are a part of the parent class. And you can add your appropriate logic from there. And then you'll, again, like I said, you'll add the methods that execute some level of change to or logic to the records. So for the example, there was the apply discount method that we saw, and this method, the method does not pass the records. Okay, so what this is saying, the method does not pass the records. When you look at the apply discount, you look at it on the discount percentage and this unit of work, but nowhere in the method does it actually pass in the records that you want to work with. Because again, when you set up the opportunities domain class, you actually provided all of the records that you wanted to work with during the constructor. So that's why I was saying the methods do not pass the records, they just are loaded when the class is instantiated. And then again, if the method is making changes to records that eventually will need to be saved, then you will add, typically at the end, the fflib S-object unit of work. And the unit of work is about, is the class that will deal with saving and persisting of these classes. And we'll talk about that a little bit later. But this is how you make it happen. And the last thing you typically add to a domain class is an inner class called constructor. And it's a very straightforward construct. This is an inner class called constructor. It implements this particular interface. And you have one method called construct. And then from there, you just instantiate the new opportunity. So let me show you that class real fast. In the opportunities class, at the very bottom, is this constructor inner class. And again, the format of this is very stock standard. It's always going to be the name of the domain class, and it's always going to be straight out S object, and it's always going to be the same name constructor. This is important because this is how the domain class will tie into the generic trigger handler framework, which is part of the Apex Common source. Because what happens is when you have that set up, then you can, let me get back over to the presentation. When you set this up, you can set up you can tie it into the trigger handler framework, which is part of the Apex Common. And the trigger setup, your trigger setup for each of the S objects becomes very simple. You're going to set it up for all events, so the after delete, after insert, after update, before delete, etc., all of them. And you're just going to provide, the entire trigger has one line, and that is the fflib S object main trigger handler method, and you pass the class, the type, the Apex type of the domain class. And that's all you need to do. And then from there, your entire logic for triggers are handled by the domain opportunity domain class in this case. So, a couple of comments about the usage notes. Again, domains typically only reference other domains. They sometimes will reference selector classes from other S objects, maybe to get some extra information that they might need to process. You will never find domains calling service tier logic or client tier logic. Again, this is you want to make sure that the domains are at the bottom, rudimentary, smallest level of the stack. And you don't want them calling out and creating circular dependencies to other things that are not needed. It's okay, again, for the domains to talk to other domains, and they can manage that through the application factory, which we'll talk about. One other thing to be mindful of is if you really want to take an in-depth look at this, take an in-depth look at that core parent class called the S-object domain. Because what you will find in is a very interesting hidden gem, which is called the test interclass and the database interclass. What this really is an in-memory mock database. And what that allows you to do is if you set up the domain pattern correctly, you can simulate all the trigger events for unit testing without actually saving records to the database. Now, that seems like a very simple concept, but you've got to understand that if you have a very long deployment process to production, it's because it's not because you're deploying a lot of the code. It's the code is being deployed, but then you're running a lot of tests along the line, and those tests can take hours. There was one job that I worked with at a law firm, and when I started there, before I started converting to the Apex Common framework, it would take deployments 75, an hour and 15 minutes, hour and a half to do a deployment because it just took forever to run all those unit tests. When we got about 50% way done migrating the code base to utilize Apex Mocks and Apex Common, a lot of the unit tests were rewritten so that they did not need to actually insert records. And just converting 50% of the code base dropped the deployment times down from an hour and a half down to 25 minutes, 25 minutes in typically what we saw. It had just the interaction with the database during unit tests, such a huge time waste. And so doing this, converting to the enterprise patterns alone, for that reason alone, is worth it. But just again, I cannot, these little hidden gems throughout this framework, this test database interclass is one of them. And it's just incredible the power that's available. So that's enough about the domain pattern. Let's get into the service pattern. Again, what is it? It's a class or a series of classes responsible for aggregating logic across multiple S objects. Again, sometimes it's viewed as a coarse-grained service. People will talk about that. And this service layer pattern or service pattern is where the typical service tier contract boundary exists. All presentation or client tier logic will interface with the service tier. You never see presentation or client tier logic interfacing with domain logic. It is the purpose and the design of the service tier to manage all of that interaction. Typically, the client tier only will call one service method per transaction. That's important as well. What you don't want to get into that habit is have a lightning page Apex controller calling multiple service methods. Because if you find that you're doing that, what probably is happening is that you've designed your service incorrectly. The client tier logic, the client clear controller classes, their responsibility is about what information do they need to massage and prep for their Visual Force page or their Lightning page or Lightning UI. They should not be responsible for manipulating it. They should not be responsible for making changes to the database. And so they should hand that responsibility off to the service layer. And the service layer will then assemble the appropriate domains across all the S objects that are important and manage that through there. Now, the examples or the classes that you need to think about in the Apex Common project for the service pattern, there actually are no key classes in there because it doesn't rely on it. There's no core classes in the Apex Common framework, but this is just a convention of the Salesforce Lightning Enterprise patterns that again helps you separate your concerns, layer your code base appropriately. So for an example, let's look at three classes: the opportunity service, the I opportunity service, which is the service interface, and then finally the interface opportunity service info. So when we take a look at that, let's take a look at the opportunity service. This is the service facade, and you'll find that it's pretty straightforward class. It has a lot of static methods, apply discounts method, and the create invoice method, and the submit invoice and job method. And all of these are accessible to any kind of client tier logic. But you also find that there is a service, typically a service static method. And this again just is a convenience method to access the application service factory. And basically you just, once you get that interface, once you access that and get the actual instance or the implementation of the service, then you call that method, which is the service. So this service class will return an interface, the I opportunities service method, and we'll look at that in a second. Yeah, the I opportunity service class is very straightforward, simple interface. It defines the methods that are available. And then finally, do I have this open? I don't actually, so let me go grab this extra class real quick. There we go. And finally, we have the implementation method. So the implementation class manages, it implements the service interface, and it has the specific methods and the logic around those specific methods. It's important that we have a separation between the actual class that any of the client tier code will utilize and the actual implementation. Again, this is all about dependency injection. This is all about a service locator pattern. But basically what it does is this allows you to go through the application service factory to find the specific instance that you're looking for. And notice that I'm passing the Apex type of the interface. And I'll show you how this application service factory maps to and returns the opportunity service info. Let's see. One thing I want to show you. Yeah. So when we look at it, again, when you're defining the default set of classes for each service, oops, sorry, I went too far. Okay, there we go. Default set of classes for an opportunity service. Well, you'll have the basic service facade, which is named opportunities and service. You'll have the interface, the implementation. You'll also usually have a service test and a service exception. So those are the 5 classes you typically set up for a service. And when you're looking at the facade, again, we looked at it, but just to highlight, all the methods are bulkified. They have parameters. They never deal with a single record. They always deal with sets of records or sets of IDs. All the methods in the facade are static. So you can call them, the instance straight. And then there always is this private static service method. And again, that's hands off to the service factory. The service interface is straightforward. Again, it's a simple interface, and methods defined in there. And then finally, the service implementation implements those methods going forward. Let's take a look at the service implementation one real quick, because the service implementation shows a lot of examples of some of the other patterns that we've already talked about. And so in the implied discounts method, what's going on is we have a unit of work, which we're going to talk about in just a second. We have an opportunity selector that goes and queries the records that we're looking for. So we had the opportunity ID set came through. We just pass that to the method. Again, since our bulkified methods all have set IDs, they just transfer immediately over. And so this queries all the opportunity records and puts it into this variable right here. Then we instantiate the opportunities domain class with the opportunity records that we have just queried for. And then we use the domain class to apply the discount that we were looking for. And that's coming from this discount percentage, excuse me. And then finally, we go back to this unit of work, which we'll talk about in a second, but we commit the changes. And so let me switch back to the presentation now. Talked about this minimal setup. But typically, as far as usage, you usually have services call other service facades. They will definitely call domains. They will definitely call selectors. And the service implementations instantiate the UOWs or the unit of works. So again, the unit of work pattern pretty much says it will hold and collect all of the data that's being changed by the service method. And then that commit method that we saw, the commit work method, will actually save all those changes until the end of the service method. And that, again, gives you the transaction boundaries that you need and looking to do. So there'll be links to other blogs about the unit of work pattern a little bit more. Let's talk about the application factory pattern real fast. Again, what is that? It's a single class. It's a single class that's responsible for mapping all of the instantiations, but it does it in a very loosely coupled way so that we have a high degree of flexibility. We are in a position where we can swap out one implementation for another. And you say, why would you want to do that? And that is because that helps with things like the mocking framework and the ability to mock certain sections of the code base and swap them out. A single application class actually defines all the static maps for the selector classes, domain classes, interfaces, and we'll take a look at that in a minute. It's used within a service method, but passed down. Okay. Actually, that was for the unit of work pattern. So I apologize. All of that was about the unit of work. So let's take a look at the application class. It from the Apex Common project, it always extends this FFlib application class. And really, there are 4 subclasses in that class. One is called the unit of work factory, the service factory, selector factory, and domain factory. The example is in the Apex Common sample code project, and it's simply the application class. And typically, you have a single application class in the environment. Sometimes you might want to prefix it, but usually it's always named application. So let's go take a quick look at that application class. It's pretty straightforward. It defines 4 variables. One of them is a static instantiation of the unit of work, and that is the FFlib unit of work factory. And so here you just add the extra pieces of the puzzle with the unit of work. So the unit of work class itself manages all the complexity around saving classes in various relationships, or so you would say, like, you have a relationship between the account and the contact. Well, before you can save the contact, you have to save the parent account record first. So if you were using a unit of work, you could add both the new account record and maybe 3 new contact records that belong to the account record. And so when the unit of work begins its process to commit all the changes to the database, it knows that the account object needs to be inserted before the contact record. Or look at lines 33 and 34. The invoice object record would need to be committed before the invoice line item would need to be committed. And the same is true that an opportunity might come before a product, and the product before a price book entry. But both the price book entry and the opportunity and the product need to come before the opportunity line item. So this represents, the way you enter this represents the sequence that the database updates will be applied. And so it manages the relationships. And so in the account contact example, it would save the account record, and then it would have that account record, and it would have, after it does the commit, it has an ID in the account. And so it knows that these three contacts belong to it as well, and it can map those in. The application factory also has the service factory, which is, again, managing the service bindings. So you saw the opportunity service. Well, you saw the interface class actually maps to the opportunity service impl. So again, when you go to the service facade and you go to the apply discounts method, what's happening is it's calling the service, which is really calling the service factory, and it says, give me the implementation for the opportunity service class, the interface. And it returns, and what it returns is actually the opportunity service impl, and then you execute the apply documents method, or apply discounts method. But that mapping is constructed right here. The same is true with the selector and the selector factory. You're binding the opportunity S object to the opportunity selector class. And you're binding the opportunity line item S object to the opportunity line item selector class. And the same is true with the domain. You're binding the opportunity S object to the opportunities constructor class. And remember the domain has that inner class called constructor. And the same is true with opportunity line items. You're binding it to the constructor class. And that's just, again, it's needed so that it can find the correct implementation going forward. So, but when you set up your application, you just basically set up this application class and define these four factories and give them the bindings that it needs. And all of the plumbing and the hard work is part of this root fflib application class. So again, it takes a little bit of research to understand all the dynamics that are going on there. But once you get it, it makes so much sense. Let's get back to the presentation. Again, we talked about the minimum setup for that, and we talked about that it's a simple class and defining four static methods, one for the selector, the unit of work, the service, and the domain. And again, the various application factories have with them each a set mock method. And so what that allows you to do is to, again, when we get into things like Apex Mocks framework, it allows you to override the default bindings that you see in the application class. So I might have, let's take a quick look. So we've got this. So let's go find the test class for the opportunity service. Here it is. So we look at the opportunity service test class. What this allows us to do is I can create a mock domain. And using again, this is the Apex mock, so I don't want to go too far into it, but basically I can tell it, say, using this interface, create a mock class, and we'll call it the domain mock. And using this interface, create a mock class for this selector interface and call it the selector mock. And then I can set up, do some Apex mock setup, and once I'm done, then I can say application factory. When you see a call, I want you to use this particular domain mock. So I will add this domain mock to my domain class. And so the domain mock, when it sees a call for the opportunity S object, it will go and use this mock class instead of the default binding that we see in the application class. And so what that allows me to do is you exercise the opportunity service and apply the discount and then I can use verification methods to ensure that the correct output is coming. But this is very important, especially when you think about the selector mocks, because the selector mock allows me to basically set it up so that when I call this method on the selector mock, I will return a specific result set, and this result set is what I basically created this opportunity record and define it. So I'm overriding the default behavior of the opportunity selector, and it will return this opportunity instead, this record. And so I have, in a deterministic way, I always can see what's going on and always test against a predefined set of records. And so, again, these set mock methods are available in all the different factories and it's a key component to the application mocks and a key component to the entire flexibility of this framework. So we're almost done. Let's talk about a couple of things. We've talked pretty much now about the key areas of the framework and the Apex Common framework. And there's a couple things to be mindful of when you're working with it. Salesforce DX is upon us, and there's some considerations to be thinking of and be mindful of. Now, what I showed you was the, we'll say, the classic implementation of Apex Common framework. But if you're going to be using Salesforce DX and the Apex Common framework, you're going to have to change it slightly. Basically, you're going to need to include two more frameworks. The Force DI, DI stands for Dependency Injection, so it's the Force Dependency Injection framework. And another framework called AT4DX. Again, both of these are found at the Apex Enterprise Patterns group. But these additional frameworks allow to a little bit more flexibility to allow the dispersion of logic and dispersion of queries and things across multiple packages. If you go to both of those projects in the README section, there will be information and Dreamforce presentations and Trailhead DX presentations that go into much greater depth about how they adapt the Apex Common framework so that it can be used within the world of Salesforce DX. But you know, some highlights: it allows you to extend the selectors and the domains so that you can have, maybe fields from one fields for an S object, and some of the fields exist in one package, and some of the fields exist in another package. And you know, it solves those questions about which project should own the fields, which one should do it, how do you update the selectors, the selector field injection, selector method injection, domain process injection. Lots of advanced concepts there. Again, just go and go to those repos to get more information about the blogs and the related webinars. So, but if you're not using Salesforce DX and don't really want to go there, then the default implementation of SFlib Apex Commons works just fine, and it doesn't lock you into something. You can easily change it and adapt for if you want to go to DX down the road. So with that, there's some more information. Again, I've been mentioning two different books quite extensively here. The first one is Salesforce Lightning Platform Enterprise Architecture by Andy Fawcett. Go to wherever you get the books, look this up. It is a wonderful read. It goes into a lot of depth, a lot of the material that I've talked about these frameworks. But it's also much broader concepts around how to develop applications at scale in the world of Salesforce. And then if you really want some really good in-depth reading, go read Martin Fowler's book, Patterns of Enterprise Application Architecture. Again, it's got nothing to do specifically with Salesforce, but it talks about all these design patterns and lessons learned and techniques to construct your enterprise application. Again, it's definitely going to be worth your time to do that. I've highlighted a couple of blogs here. I know that Amit is going to post these as well when he posts this recording. But again, these are some of the early blogs that Andy Fawcett did around Apex Enterprise Patterns, and where you can get more information. And with that, I'm pretty much done, Amit. There you go. So.
Thank you, John. That was a really helpful session, and lots of things like all the developer need to check. And the last slide, whatever you show, the dependency injection with the SFDX, that is a very common and interesting stuff you used to face when you are trying to create unlock package. So I was also facing same kind of issue, and that particular repository helped me.
Yeah, good to hear. Very exciting. Yeah.
Thank you so much for joining us and sharing your knowledge. I really appreciated your sharing your knowledge and time with us.
I thank you for the invitation, sir. I do appreciate it.